All right, let's dive right in. If you're getting ready for a junior Java developer interview, you are in exactly the right spot. Today, we're going to break down the absolute must-know concepts that can take you from feeling anxious to feeling totally confident. Let's get to it. So you did it. You landed the interview. That's awesome. But now the big question is, what do you actually need to know? What are they really going to ask you? In the next few minutes, we're going to walk through the core questions and concepts that come up again and again, so you can walk into that room ready for anything. First things first, you've got to have a rock-solid foundation, right? Interviewers need to see that you get the basics before they trust you with the really complex stuff. So let's start with the essential keywords and components that really make Java work. So what exactly is a constructor? Well, think of it as the setup crew for a new object. It's a special method that gets called the second an object is created, and its whole job is to get that object ready to go. There are two dead giveaways. Its name is always identical to the class name, and it has no return type, not even void. Now, this is a big one. Where you declare a variable really matters. A local variable? That's declared inside a method, and it only exists inside that method. It's like a temporary note on a napkin. You use it for a quick calculation, and then it's gone. An instance variable, on the other hand, lives inside the class but outside any method. It's a permanent part of the object's identity. You know, like its name or age, and it's accessible from anywhere in that class. Okay, the static keyword is all about being efficient with memory. When you mark something as static, you're basically telling Java, hey, this thing here, it belongs to the class itself, not to any single object. This is so important because it means you only have one copy of that variable or method, and it's shared by all the objects. You don't waste memory creating a new copy for every single instance. And the best part? You can use it without even creating an object first. And then there's final. Think of this keyword as the lock it down tool. You can make a class final, which means no one can extend it. You can make a method final, so a subclass can't change it. Or you can make a variable final, which means its value can never, ever be changed once it's set. It's how you create things that are predictable and safe. So those keywords are the building blocks. Now, let's use them to talk about the most important part of any Java interview: object-oriented programming. I'm not kidding. Nailing this section is absolutely crucial.
Overloading and overriding, they sound so similar, but they are completely different animals. Overloading is when you have multiple methods in the same class, with the same name, but they have different parameters. The compiler figures out which one you mean at compile time. Overriding, however, is when a child class gives its own special version of a method that it inherited from its parent. That decision gets made at runtime.
Here it is, the classic interview question. You're almost guaranteed to hear this one. They want to see if you understand a fundamental design choice in Java. So why can a class only extend one other class? The answer, in 2 words, is the diamond problem. Just imagine a class tries to inherit from 2 different parent classes, and both of those parents have a method with the exact same name. Which one should the child use? It's totally ambiguous, and Java was designed to just avoid that mess entirely. So, how do we get that same kind of functionality? Well, Java has a really elegant solution: interfaces. A class can't extend multiple classes, that's true, but it can implement as many interfaces as it wants. This lets you borrow behaviors from all over the place without running into that nasty diamond problem.
This brings us to another key comparison: abstract class versus an interface. An abstract class can have a mix of regular methods and abstract methods that must be implemented. An interface is typically about 100% abstraction, just the method signatures. Here's a tricky detail, though. You can't create an object of either one, but an abstract class can have a constructor, which gets called by its children. Let's clear up 2 more really important keywords. This is simple. It's a reference to the current object. It means me, the instance of the class that I'm inside right now. Super, on the other hand, is how you refer to your immediate parent class. It's your way of reaching up and saying, hey, I need to use a method or a variable from the class I extended. Okay, let's be real, code doesn't always go according to plan. A great developer isn't someone who never makes mistakes, but someone who knows how to handle them gracefully. This next part is all about exception handling, and it shows an interviewer that you can write code that's tough enough for the real world. Here's another pair that trips people up all the time: throw versus throws. Throw is an action. You use it inside a method to explicitly create and throw an exception right then and there. Throws, on the other hand, is a declaration. It goes in the method's signature, and it's basically a warning label that says, hey,
Just so you know, this method might throw this type of exception.
And what if Java's built-in exceptions just aren't specific enough for your needs? No problem. You can make your own. And it's actually super easy. It's just 3 steps. 1. Create a new class. 2. Have it extend the main exception class. And 3. Use super to pass your own custom error message to the parent constructor. That's it.
All right, let's pull the curtain back a little bit. To really truly understand Java, you need to know a little something about the environment it runs in. So let's quickly demystify those 3 big acronyms: JDK, JRE, and JVM. So at the very top, you've got the JDK, the Java Development Kit. This is the whole shebang. It's the entire toolbox for developers. It has everything you need to write your code, compile it, debug it, and run it. Nestled inside the JDK is the JRE, the Java Runtime Environment. This is what a user needs on their machine to simply run a Java application. It has all the necessary libraries and the JVM, but not the developer tools like the compiler. And at the very heart of it all is the JVM, the Java Virtual Machine. This is the engine. This is the magic. It's a virtual machine that takes your compiled Java bytecode and translates it into the native machine code that your specific computer can understand. This little piece of genius is what makes Java write once, run anywhere. Finally, let's talk about data. Because, let's face it, storing and managing groups of objects is something you're going to do every single day as a developer. And thankfully, the Java Collections Framework gives us a ton of powerful tools to get that job done right. So, at the most basic level, what's the difference between a plain old array and a collection? It all boils down to one word: flexibility. An array has a fixed size. You decide how big it is when you create it, and that's that. A collection, like an array list, is dynamic. It can grow and shrink on the fly as you add or remove things. That's why for most situations, you're going to reach for something from the collections framework every time. So if you only take one single thing away from this whole explainer, let it be this. We've heard it straight from experienced interviewers. You have to have a deep, confident grasp of object-oriented programming. Concepts like abstraction and polymorphism aren't just buzzwords. They're the absolute key. If you master those, you're going to be in fantastic shape. We have covered a ton of ground, from the simplest keywords all the way to the JVM itself. You now have a map of the core knowledge you need for that interview. So the final step, well, that's up to you. Take a second and think, which of these topics made you feel a little uneasy? Which one is your weakest link? That's what you should focus on. Now go get 'em. Good luck.